Moving water through a modern city requires massive industrial scale. It takes electrical grids, high-pressure reservoirs, and synchronized motorized pumps just to keep the taps flowing. 2 millennia ago, before the invention of the electric motor, ancient Rome had constant, gushing running water, feeding public baths, street fountains, and private homes. The geography made this nearly impossible. Rome's fresh water sources were trapped in mountain springs dozens of miles away, separated from the city by jagged, inhospitable terrain. The Romans had no electricity and no machines to pull that water across the distance. To sustain over 1 million lives, they had to move an entire mountain river into the city center, using nothing but structural engineering. Their solution relied on a single, limitless energy source: gravity. This diagram shows the core engineering principle, the continuous gradient. To keep the water moving, engineers calculated a slope that dropped only a few inches for every 100 feet of distance. If the slope was too steep, the water would accelerate until its kinetic energy destroyed the stone walls. If the slope was too shallow, the water would lose momentum and stagnate before reaching the city. Maintaining this precise slope across the countryside effectively turned the entire project into miles-long mathematical equation. But the landscape rarely accommodates perfect math. When a water channel hit a deep river valley, the lack of pumps meant the water couldn't simply go down one side and back up the other. To maintain the elevation, the Romans built monumental, multi-tiered arched bridges to hold the water channel in the sky. The very top tier of this structure is leveled to maintain the exact necessary slope, keeping the water moving steadily across the valley floor below. These artificial horizons of stone stretched for dozens of miles across open country and rolling plains. Roman engineers dominated the landscape, ensuring that their mathematical slope remained unbroken, regardless of the cliffs or valleys in their path. When the water finally reached the city, it arrived with constant momentum. Because it was entirely gravity-fed, the flow could never be turned off. This pressure was routed into a distribution network of thick lead and stone pipes. This system powered hundreds of public fountains, private villas, and massive bathhouses throughout the day and night. But a constant intake of millions of gallons meant millions of gallons had to be removed. This was the hidden half of the system, a subterranean sewer network that used the leftover momentum of the aqueducts to continuously flush waste out of the city. Linking high mountain springs to these subterranean sewers established a continuous cycle of fresh water input and waste removal. Mastering gravity transformed Rome from a cluster of hills into the ancient world's first true metropolis. Because this system relied on stone and physics rather than complex machinery, significant portions of the infrastructure remain intact today. Modern civil engineers still follow this exact logic of gravity-fed distribution to hydrate cities and manage waste. Ancient Rome proved that a massive, high-density city could survive by mastering its water, providing the logic still used to build